a hugely neglected
Richard. Planning to get off the road. Experience of this.
Don't know what I just did, but it worked.
Okay, so our next speaker in this symposium is Lisa Cipolotti, who is a professor of neuropsychology here at UCL, and she's going to talk about the role of the prefrontal cortex in fluid intelligence, abstraction and reasoning. So thank you very much.
Thank you very much. Good afternoon. It is a real pleasure and an honor to be here and to participate to this special symposium. So special thanks to Nikki Helstein and Richard Beaming for inviting me here. And yes, I am professor UCL, but in reality, for the past 31 years, my role has been fully NHS clinicians. So today I would like to discuss with you the role of the prefrontal cortex in fluid intelligence, abstractions, and reasoning. These complex skills are part of what Shelley and I describe with the terms of active thinking. Active thinking refer to our ability to solve novel problems, to reason, to produce strategies and plans. Unsurprisingly, active thinking does not only entail fluid intelligence and abstraction and reasoning, but also it entails other complex cognitive processes such as judgment, inhibition, strategy formation, verbal and nonverbal generations. Lesions to the prefrontal cortex are known to impair several of these complex processes. Today, as I already said, I'm going to focus on fluid intelligence, abstraction, and reasoning. My presentation aims to discuss the following. First, the relationship between fluid intelligence and other executive processes. Secondly, the neuronal basis of fluid intelligence. And thirdly, if different aspects of fluid intelligence are lateralized. In particular, I will discuss task setting, abstraction, and analogical and deductive reasoning. So, to start up with fluid intelligence. Fluid intelligence is arguably one of the most defining features of human cognition. And in theme with the rest of the afternoon, it has been relatively poorly investigated, particularly from a neuropsychological perspective. So let me define fluid intelligence. Fluid intelligence is often referred as the ability to solve challenging novel problems when prior learning or accumulated experience are of limited use. Fluid intelligence is known to correlate with many cognitive abilities and predict educational and professional success, social mobility, health, and longevity. Despite the critical importance of fluid intelligence, several important aspects remain poorly characterized. For example, it remains contention its relationship to other cognitive domains, in particular executive functions, and its brain basis. So, to start up, what is the relationship between fluid intelligence and executive functions? Well, an influential proposal suggested that a deficit in fluid intelligence can explain most of the reported executive impairments in frontal patients. This is because fluid intelligence is positively correlated with tests of executive functions and is often impaired following frontal lobe lesion. For example, Rocca et al. Reported that when performance on a fluid intelligence test was taken into account, no difference was found between frontals and healthy controls on several frontal executive tests. So, is a reduction in fluid intelligence sufficient to explain frontal executive impairment? I will discuss some of our studies that we have conducted using the Raven Advanced Progressive Matrices. From now on, I will refer it as APM. This is an example of the APM. In this task, the participants are presented with patterns where there is a missing piece, and they are asked to complete the pattern by choosing between one of the options below. So is there evidence that performance on tasks such as this one which is one of the most commonly used tests of fluid intelligence, is sufficient to explain performance on frontal executive tasks. We conducted a series of studies investigating 8 different frontal executive tasks in groups of frontal and posterior and healthy controls. And as you can see from here, we found that frontal patients were significantly more impaired than posteriors and healthy controls on all of these 8 executive tasks. However, none of the impairments on these tests can be explained by APM performance alone. So these findings suggest that fluid intelligence is not sufficient to capture frontal executive impairment. And this suggestion has been further strengthened by our investigations on 2 patients who show selective preservation of fluid intelligence despite severe frontal executive impairment. Both patients have received the clinical diagnosis of frontotemporal dementia. Here you can see their MRI findings. And for the purpose of this lecture, I would just like to draw your attention on the fact that in both patients, there was a relative preservation of right frontal and parietal cortices. So how did the patients present? You can see from here that both patients presented with severe behavioral impairments. For example, both patients presented with inappropriate social behavior. How was their performance on frontal executive tasks? As you can see from here, both patients performed very poorly on a series of frontal executive tasks. For example, they even failed the Weigel test. This is the simplest executive test. In a test like this one, the patients were only able to give one of the 2 solutions. So how was their performance on fluid intelligence test? Well, I would say their performance was pretty good. Here you can see their performance on, sorry, I lost the, here you see the performance on several versions of the Raven progressive matrices, and you can see it's pretty much preserved. And also their performance was well preserved on an additional fluid intelligence test, termed the Cattell test. So despite sparing of fluid intelligence, severe executive impairment can occur. This supports the notion that a single factor, fluid intelligence, cannot account for all executive performance. And it raises the possibility that there may be a separation in the architecture of frontal functions between processes mainly involved in fluid intelligence and those involved in other executive components. So we saw that fluid intelligence can continue to operate despite severe frontal executive impairment and cognitive decline. This led us to investigate the minimal computational substrate of the APM using an artificial neural network called LAMA, and to hypothesize that perhaps a more localized set of cortical regions than previously thought may underpin fluid intelligence. And this motivates us to conduct a lesion study on a large sample of patients. So due to time constraint, I will briefly mention only one of the results that we obtained with the LAMA model. So this study has been conducted by Amy Nelson, which is the PhD student that I'm co-supervising with Paresh Nachev. So LAMA is a minimally constrained, self-supervised in-painting model. It is trained solely on the completion of partially masked images of natural environmental scenes, such as buildings and landscape. Basically, the model has been solely trained to complete partially occluded images. LAMA learns information on how to paint in a designated region of an image from information contained in the reminder. This model is doing so without prior exposure to images of the same kind. So here you can see one of the questions of the APM, and here you can see one of the answers of the LAMA model. So basically, the model managed to paint in the correct answer despite having been previously solely trained in outdoor naturalistic scenes. Surprisingly, the model achieved an IQ of approximately 106 a prima vista without any task-specific inductive bias or training. This is rather remarkable since the model can only integrate global spatial pattern. So, our deep learning modeling of the APM suggests that the APM minimal computational substrate may simply require the interpolation of spatial patterns. This does not imply that it can be dismissed as merely visual spatial. The APN may correlate with verbal and visual spatial reasoning, abstraction, cognitive control, and working memory. However, it does not necessarily require them. The fact that such processes are not required by the APM does not mean that they're not invoked. Perhaps most subjects solve APM-style problems through reasoning involving commensurate time and perceived intellectual effort. So let me now move on and address the second point of my lecture. What is the neural basis of fluid intelligence? Well, two main proposals have been put forward regarding the neural basis of fluid intelligence. Both proposals rely heavily on functioning neuroimaging data, primarily on healthy controls, and they suggested close links between frontal and parietal areas. Here are the two main proposals. The first one is the multiple demand hypothesis that suggests that the network of frontal and parietal areas, termed the multiple demand network, is the seat of fluid intelligence. According to this hypothesis, patients with or without multiple demand network damage should differ significantly in performance on the APM. The second proposal is the parietal frontal integration theory. This theory suggests the fluid intelligence involves a widely distributed network involving parietal, frontal, but also occipital and temporal areas. Hence, fluid intelligence impairment should occur following posterior and anterior lesion. Unfortunately, until very recently, very few lesion studies which have a great causal powers have been conducted. These studies are almost all small, methodologically constrained, and produce inconclusive results. And for example, the lesion studies that have been reported using the APM have reported no difference between right or left hemisphere patients, impairments in left hemisphere patients, or impairments in right hemisphere patients. We relatively recently conducted a study on a large sample, 227 patients with focal unilateral lesion and healthy controls. Mindful of the time time constraint, I will present only some of the main results we obtained on this study. As you can see from here, frontal patients were significantly more impaired than posteriors and healthy controls. Critically, we found that the right frontal patients were significantly more impaired than the left frontal patients. Interestingly, we found the three medium difficulty items of the APM was bringing the greatest lateralization. And here you can see an example of these three items, where the right frontal were much more impaired than the left frontal. And we argue that these three items require inferences on the perception or the progression of a pattern. We also found three non-silly items of the APM that show the least lateralization between left and right frontal patients. And we argue that for this item, addition and subtraction come into play. So the limited numbers of items of the APM precluded any firm conclusion. However, these findings preliminarily suggest at least that components of the APM may lateralize in different ways. And we explore anatomical questions further. We conducted several neuroimaging investigations thanks to the expertise of Paresh Kernachev and his group. And basically, we found that neither the presence nor the extent of the multiple demand network lesions affected APM performance. Standard lesion deficit analysis implicated the right posterior middle frontal gyrus, the pars opercularis, and the precentral gyrus. We also adopted novel network modeling capable to disentangle the effects of APM performance from lesion co-occurrence. And basically, our analysis using Bayesian stochastic block models implicated the right middle and inferior frontal gyrus and pre and post central gyrus. So I would like to argue that these findings suggest that our approach of combining detailed investigation of APM performance in a large sample of patients with novel lesion deficit mapping provide crucial information about the neural basis of fluid intelligence. A right frontal network rather than a wide set of regions distributed across the brain appear to be critical to the high-level inferences based on perceiving pattern progression involved in fluid intelligence. So, what about other aspects of fluid intelligence? Are they also lateralized? And I would like to start by discussing task setting. The H4 is a verbal test of fluid intelligence. It requires to solve several subtests. And one of the subtests is the multi-stage calculation subtest. And this is one of the examples of this subtest. And for example, here the patients are presented with problems such as, here are 3 figures, 2, 3, and 4. Divide the biggest figure by the smallest and add the result to the figure printed immediately after the smallest figure. We argue that in order to solve problems such as this one, you require several processes, and in particular among these, you require a process called task setting. That is our reasoning ability that involved in setting up a program to guide action. This is because the task that we just saw together specify the steps to be completed, but the order in which each step needs to be completed does not correspond to the order in which they must be completed. Hence, an essential prerequisite to solve the task is the construction of a schematic representation of the problem within which to insert the mathematical operations. And what did we find with this kind of problems? Here you can see our main results. Again, is a test for which frontal patients are significantly impaired when compared to healthy controls. However, in this case, we found that the left frontal patients were significantly more impaired than the right frontal patients. So we would like to argue that these findings suggest that specific reasoning abilities, such as those involved in task setting, appear to be lateralized to the left frontal lobe. And what about other aspects? For example, abstraction. Abstraction is often considered an important desideratum of intelligence. For example, according to the influential Cattell, Horn, and Carroll theory of human intelligence, abstraction is considered part of fluid intelligence broad abilities. We consider it a key mental process involving active thinking, and it has been thought to be a key factor contributed to the frontal lobes in fluid intelligence. Proverb interpretations have often been used to evaluate abstractions. This is because proverbs assess our ability to interpret a statement in an abstract rather than in a concrete sense. This is because the proverb meaning must be generalized to more scenarios than the one reflected literally in the proverb itself. So, for example, for Rome was not built in a day, a generalized understanding is that any great achievement, Rome, takes patience and time to complete, wasn't built in a day. A concrete or literal understanding of the proverb may refer to the length of time it takes to complete a building or the length of time it took to establish the Roman Empire. Unfortunately, relatively few lesion studies have investigated proverb interpretation, and these studies have typically involved very small number of patients and are generally lacking anatomical analysis. We recently conducted a study on a large sample of patients with focal unilateral lesions. And again, mindful of the time, I will present only some of the main results. As you can see from here, we found that left and right frontal patients were significantly more impaired than posterior and healthy controls. However, critically, the left frontal patients were significantly more impaired than the right frontal patients. So these findings suggest the probable interpretation may lateralize to the left frontal lobe. And using our novel network modeling, we explore further anatomical questions. And our Bayesian stochastic block models analysis implicated a strongly lateralized, extensive left frontal network, predominantly involving superior and medial frontal gyrus. We also analyzed the errors that the patients made, and we found that left frontal patients made significantly more concrete error than right frontal patients. And here you can see an example of one of the errors of the patients. The grass is always greener on the other side was the proverb, and the patient said, well, you always think everything is better in your neighbor's garden. We just started to analyze further proverb performance and concrete errors using a large language model. And I simply could not resist the temptation to share with you one of our very, very preliminary results. And let me stress they're super preliminary. Basically, our large language model behaves exactly like a left frontal patient when degraded. Here you can see example of the progressive concreteness of the answer that the model gave when damaged. So the model starts with a perfectly good abstract interpretation. For Rome was not built in a day. The answer is that things take time and effort to complete. It is not something that can be done quickly. But more it was damaged, more the answer became concrete up to it was built in the night. So I would like to argue that our results suggest the proverb interpretation engages a set of specialized cognitive processes involved in constructing abstract representation. And these processes are underpinned by a left frontal network. Concrete errors are a measure of frontal executive impairment, at least as sensitive as overall performance. Of course, it can be argued that the visual verbal nature of the raven, the H4, and the proverbs may have contributed somewhat toward the lateralized effect that we discussed together so far. So I will now like to move to the last point of my lecture, and I would like to address this very important point directly by presenting our study on analogical and deductive reasoning. First of all, let me remind you what analogical and deductive reasoning are. Analogical reasoning is the process of identifying similarities between relationships. So for example, a fish is to a swim as a bird is to, and deductive reasoning is the ability to derive a logical conclusion from a set of premises that are held to be true. So if A is bigger than B and B is bigger than C, A must be bigger than C. Analogical and deductive reasoning are considered to be the hallmarks of fluid intelligence, according to the Cattell and Horan-Carroll theory, and key mental processes involved in active thinking, allowing for novel behavior. The neuroanatomical basis of analogical and deductive reasoning has been mainly investigated with functional neuroimaging studies, which have reported very mixed results. In terms of lesion study, literally, all I could find were 3 studies for analogical reasoning and 2 for deductive reasoning. And it's fair to say that the results were again rather mixed. For the analogical reasoning task, one study reported no difference between anterior and posterior patient, another impairments in frontal and temporal patients, and another impairments in left frontal patients only. For deductive reasoning, the 2 studies reported one reported left frontal lateral superior medial impairments, but no right frontal impairment, and the other one reported right and left frontal impairments. And let me stress that these studies involve a very small number of patients, One of these, for example, were 10 patients. So we recently completed a study using a large sample, 247 patients with focal unilateral focal lesion and healthy controls. And for this study, we designed two novel analogical reasoning and deductive reasoning tasks. And here you can see example of our analogical reasoning and deductive reasoning questions. For the purpose of today's presentation, I just want to focus your attention that our deductive reasoning tasks was a purely verbal task. The questions were purely verbal. And again, because of time constraint, I will focus just on the main result. And as we can see from here, for the analogical reasoning task, we found that left and right frontal patients were significantly more impaired than posterior and healthy controls. However, the right frontal patients were significantly more impaired than left frontal patients. For our deductive reasoning test, which let me remind you is a purely verbal task, we found that only the right frontal patients were significantly more impaired than posterior and healthy controls. So our findings suggest that aspects of analogical and deductive reasoning are lateralized in the right frontal lobe. This is regardless the pure verbal nature of our deductive reasoning tests. And our neuroimaging results are also encouraging. Here you can see that in this new sample of patients, our Bayesian stochastic block models implicated in the same sample of patients, the right middle and inferior frontal gyrus and the pre and post central gyrus in analogical reasoning, deductive reasoning, and in the APM performance. So the neural basis of analogical reasoning, deductive reasoning, and APM seem to be implicated a right lateralized frontal network. This is regardless the verbal and non-verbal nature of the task. So let me now move on to my general conclusion. We discussed today that fluid intelligence is not sufficient to account for frontal executive impairment. Fluid intelligence is not a unitary cognitive ability supported by a large bilateral anterior and posterior network. Fluid intelligence seems to be supported by lateralized right and left frontal networks. These lateralized frontal networks appear to be involved in specific subprocesses. A right frontal network appears critical for inferences on the perception or progression of a pattern, analogical and deductive reasoning, and the left frontal network appears critical for task setting and abstraction. So thank you very much for your attention, and many thanks to my collaborators.
Okay, thank you for a fascinating talk. We've got time for a few questions. Nikki, Narinder.
Lisa, thank you very much for a fantastic talk. I have a question about the involvement of the pre-central and post-central gyri. And I was just wondering how those areas fit into your model of fluid reasoning.
Fit into my model of fluid
fluid intelligence. So you talked about the neural basis involving activation or areas of the pre-central and post-central.
Yes,
gyri.
these were the area with which we found the maximal relationship with our analysis between performance on the APM and lesion, disentangling the effect of co-occurrence of other problems. So it's a surprising new areas. We didn't expect it, but this is where we found, and we replicated with the second study. So it's complete new discovery, and we didn't have a sort of pre-assumptions of which area were involved. But they seem to be very solid because, as I said, we now confirm it on two separate samples of rather large patients.
The reason for asking is that in an unpublished meta-analysis of resting state network connections with the thalamus shows hyperactivation in the precentral and postcentral gyri. So it's an interesting comparison really between your findings with the fluid intelligence and inferential judgments.
Yes, this is on a review. I'm not familiar with the paper you're quoting, but I assume is on healthy control.
No, on patients with
Okay.
schizophrenia.
Okay, so I'm not familiar with this literature, but definitely an interesting thought. I will look into it.
Thanks so much for a very interesting presentation. If I could just make a general point, maybe a couple of technical ones. Just a general point. As you know, Muriel Lizak published this well-known paper saying IQ rests in peace, and whether the word intelligence is useful in neuropsychology. I'm just wondering whether just calling it reasoning and not using the word intelligence. And just on a couple of technical points, you mainly use the advanced progressive matrices. I'm just wondering if other tests like the visual puzzle subtest, other nonverbal reasoning tests, would you get similar effects? And the second technical point is just since education is closely related to performance and all these various tasks, were your various groups matched for education?
So I got the first question, and the answer is interesting. Yes, it's a good possibility. We at the moment we only have data using the APM for our lesion analysis, and then the new analogical reasoning. So it is possible, but I don't know. I don't have any evidence. I'm not quite sure the second question about education. What are you asking?
Just whether your various groups were matched for education.
Oh,
Since
yes,
that seems to relate to.
And we cover all our results also for premorbid scores as obtained in the NART.
Okay, thank you very much indeed for a great talk. Yes.